All right, guys, so that's sort of impacted on our time in class for the presentation. So we'll try to get through this presentation today quickly, and hopefully you'll be able to do the worksheets for homework or in a tutorial, okay? So sorry about that. I just wanted to get us started with the assignment straight away, so because I know it's been delayed a little bit. So, yep. What? Oh, enrollment key. I'll add you later. Just focus on the information I'm going to give you right now, okay? So you just enrolled, did you? Okay, what was your name anyway? All right, I don't think I've seen you on my roll, so you're definitely new to me at least. All right, that's okay. We'll deal with it as we go. So the good thing is you have all your resources already on the Learn once you get in. All right, so guys, let me just get back to my reset. Let me just restart my virtual machine again so we can get to the right spot. So today we're going to look at storage. Okay, so storage is one of those things we all know we store files. Okay, we all know we've got hard drives in our computers. We all know that the hard drive space is dependent on the hardware, but we also know that we can partition the hard drive by creating smaller parts of that hard drive and creating them as volumes or partitions. So today what we're going to look at is an overview of your storage options with Windows 10. We'll manage disks, partitions, and volumes. We're maintaining disks, volumes, and we'll talk about storage spaces, and we'll talk about OneDrive, as well as the idea of virtual hard disks. So first of all, what we're not going to talk about is we're not going to talk about network storage too much, because that's something that's coming up. That's something that's coming up in your server subject. So today, so obviously there's all sorts of different storage options for a Windows 10 computer. It's more and more so these days than before. So we've got local storage. When I say local storage, it means the hard drives that's in your computer case, or even those ones that you are plugged in with your USB, external hard drives. They're all local because they're all physically connected to your local computer. So they could be SSDs like we discussed before, solid state hard drives, or hard disk drives, HDDs. The difference between SSDs and the HDDs, or hard disk drives, is that the one has moving parts and one doesn't. And one's got high IOs per second, which lends itself to multiple virtualization, and one doesn't. One's faster, SSD, and mechanical hard drives are slower usually. Mechanical hard drives have been around for years, literally decades. But SSDs has sort of caught on only in the last 10 years or so, and it's becoming more and more obvious, popular. You'll find that most laptop computers these days sold don't even have mechanical hard drives. They only include solid-state hard drives. There's also virtual hard disks. Okay, we spoke about virtual hard disks in relation to virtual machines, but did you know that we can actually create virtual hard disks in Windows 10 and use them as if they were hard drives? What does that mean? It means that instead of actually storing files on a physical hard disk, we are actually creating a virtual hard disk, connecting as a drive and storing files inside of that. So really, the virtual hard disks are just files on something else, aren't they? So they usually have a VHD extension or VHDX extension, and basically there's some limitations on that. But we most often know virtual hard disks in relation to virtual machines. And you'll realize that VHDs and VHDXs are what we use in Hyper-V virtualization as well. But we can certainly take our physical Windows 10 machine and even get them to boot from virtual hard disks as well. Then there's server-based storage. There's file servers. Okay, file server is any computer that has files that's shared on the network. If it's a Microsoft computer, it would do what's called sharing, and it will use what's called SMB, server message block, as the protocol. NASs, network attached storage. I like file servers, except that they are usually small devices that has hard drives in them. Who's got an NAS at home? You do? What do you got? Or Brett? Oh, you attach the portable hard drive to the router. Yep. So yeah, yeah. What's your router? Fritzbox, same as me. Okay, so good choice. Not promoting that in any way. But if we actually, I also have a QNAP at home. Not promoting that either. So QNAP is, if we look at it, it's like this. Okay, this is a little device, and all these slots are for hard drives. You buy this about $569. You probably think, oh wow, that's cheap. Well, it doesn't have any hard drives just yet. Okay, this device or a device like this will be for a small business or home. You can certainly get lot more beefier NASs as well. So if we actually go to QNAP shop, you can see that you can actually get, you can get NASs that don't even look like NASs anymore. They look like, actually, these are enterprise NASs. They look like servers. Look, they're $6,000 something. They look like things that go into a rack like that in the corner of our room here. So you can get all sorts of different levels, okay? But the one I've got is something like this, okay? And you buy hard drives. You can buy Western Digital red hard drives, which are specifically for NAS devices. And I'm not recommending them either, but you can put them in, and basically what usually happens is there's a small, the CPU, there's memory, there's an operating system. The operating system is usually some Linux-based operating system, and you use a web interface to actually create these file shares and network drives and so forth. If NASs are for small businesses and home businesses or home, then SANs are the opposite. It's what's called a storage area network. It's a whole network of storage devices, and then it's actually high speed, and it's actually dedicated for a large enterprise. Okay, and if we said our NASs were a couple of $1,000s, you can get SANs which are in the thousands of dollars up to $100,000 or more, depending on how much storage you need. And most enterprise virtualization usually stores their virtual machines on SANs. So here's a network. Here's some diagrammatic representation, a NAS. So it's on a network. These are NAS devices. And the NAS, if they're Linux-based, they can use NFS, Network File System. Or if they're Windows-based, they can use the CIFS, Common Internet File System, which is SMB, which is that Windows share that I was talking about before. Here's a SAN. So you got a whole network of storage devices, devices and storage units, or logical units, or lungs as they refer to. But like I said, don't get too caught up on these names or acronyms, because we'll be covering them in further detail when we get to the server subjects. But then the servers actually then connect to these storage devices, not your clients, you notice, not your clients, but servers. Because these servers could be mounting these storage devices as local devices through what's called iSCSI, fiber channel over the Ethernet. And yeah, that's really high level. And like I said, if these were Hyper-V servers or vSphere servers, they might be using iSCSI or fiber channel, and they're storing the virtual machines here, but they're executing or running the virtual machines here. And we'll definitely look at that if you go on to the diploma networking. There's cloud-based storage. We all should be familiar with this because we use it. OneDrive. Who's not got a OneDrive here? No one, because everyone who's a student here gets a OneDrive. Okay, so I think that's pretty obvious. It's stored in the internet somewhere. The cloud, it's called the cloud because there's no fixed shape. There's no fixed size. It sort of shrinks and grows and fluffs around as much as you need, as little as you need. So that's generally the cloud. Cloud means on the internet, so it means if I've got Office 365 as my storage, it means I can go anywhere, to any computer, any device, and access my files. as long as I've got internet connection, which makes it really good. I never lose my files. I'm never caught short when I need a file that's on my OneDrive. I can go on my phone and share it with you if I had to. So with OneDrive, you get 5 gigs free storage for anyone. But if you're Office 365 customer like you guys are, you get 1 terabyte. That's quite a lot of storage on the internet, which is not costing you guys anything, is it? And it automatically copies the camera roll from your phone or tablets up there and send everywhere. You save your storage, local storage. You don't need much local storage because you're constantly uploading or downloading. OneDrive and Windows 10, you can synchronize it, selected folders, selected devices. For example, you might notice my computer here. Let me just change this one. I'll set it as the main monitor. If it's the main monitor, you'll see that there's a little icon here that says OneDrive is processing changes. That's actually my OneDrive. That's for my TAFE SA. You can see that I've got 1 terabyte, like we said, because I'm a OneDrive customer like you guys are for TAFE SA. And I have used 130 gigs. One location is syncing. I can stop sync if I wanted to, and I can unlink this PC, which means I don't want to replicate or synchronize this computer. That's a good idea, actually, because you'll be jumping the computer to computer, and you could be synchronizing it. Okay, but the good thing is, just because you're linked doesn't mean it's actually downloading the files. Okay, you can see these are all my things. I can even have a breakdown on how much I'm using here and so forth. Let's go down, go back here. If I look at my Windows Explorer, which is your main file management tool, you can see that you will automatically get a OneDrive. I do anyway, because that's how we set up here. You have to add your work or school account on there. You can see that, hey, I've got TAFE SA, I've got my classes, I've got our WOSF, and these are all my teaching resources. And you can see that a few of them we've done and a few of them are to come. But you notice the icon here, that's a cloud icon. That means it's not on this local machine. It's actually in the cloud. But if I actually right click now and click always keep on this device, whoa, it's going to download these things or synchronize these things from the cloud and keep a local copy. Okay, but that's a bit of a waste of your local storage. You can see these are green, these are synchronized. So OneDrive, really good. The other good thing about OneDrive is that I can, if you guys create a video or something, let's say this is a video, I can actually share. Because it's too big to upload to Moodle or Learn, I can just click share and I can say, who do I want to share this file to? Well, if you're on the, I can just type Barrett. He's an IT lecturer. I'm sure he won't mind getting a file from me. And when I click send, he'll actually get a link to that file and the permissions for that to access that file. So that's how we would like you guys to hand up some videos or some files which are too big to upload to the Learn side. And here, you see I've given some access. So there's a little icon with a user sort of head there, if you can see that. I can actually look at that again, and I can copy a link as well. I can share with more apps, and I can actually share this link with anyone. If it's a public link, meaning that if it's a file I want to give everyone, I can make a public link, or I can choose specific people. I can choose people who have the link. So there's many things that I can do. I can say block downloads so that they can't actually download the file. They can view it, but they can't download the file. Not that I can also allow them to edit so we can collaborate together. Well, so basically they're not downloading the file with editing, they're just leaving it on OneDrive and then editing it. All right, so let's keep going. So besides, sorry, now that I've changed the main monitor, it's actually changed the display a little bit. So let's change it back. All right, so bear with me. So OneDrive. There's also Azure storage. So OneDrive is part of Office 365, but Azure storage, if you've never heard of Azure, Azure is Microsoft's cloud platform. So what if I want to actually store more than just my personal files? What if I've got a organization and I want to use it as my backup, or even just a central repository for all of my files, so it's actually in the cloud everywhere? Okay, so or something like that, if you want to put it like that. It's similar like that, because besides just having individual OneDrives, we can have blob storage, table storage, queue storage, file storage for organizations. We can also use Azure for our virtual machines. So Azure has many levels. There's applications as a service, which is like what you got with the Office 365. There's platform as a service, which is like your websites, where you put up new websites which use like a SQL database in the background, this other thing in the background, and these other packages. That's already there. You just put your websites on. So that's a platform as a service. And there's infrastructure as a service, which is full virtual machines, virtual networking in the cloud. Let's talk about disks. So disks can be MBR or GPT. Okay, MBR, master boot record disks, are the old traditional disks. They contain partitions, primary partitions and extended partitions. But you can see that the maximum size is 2 terabytes. Well, that in the day when it was invented, 2 terabytes was enormous, because the first hard drive I ever had was only 540 megs. And that I'm not one of the first people to have computers, 540 megs. So relative to 2 terabytes, that's nothing, right? So that's why this is old, and 2 terabytes seemed like a huge number that day, back in the day. But these days, 2 terabytes, it's not that big. We can get a lot bigger individual hard drives than 2 terabytes now, can't we? Sorry? Let's look it up. Sorry. I'll just go here for a quick price list. So let's have a here it is, PDF catalog. I know they've got a nice website now, but I still prefer my PDF. Oh, here it is, parts list. All right, 3.5 inch here. 8 terabyte hard drives. That's one single hard drive. $315. It's not even that expensive for the amount of storage you get. So basically, well, could we put a MBR, make that into an MBR disk? Nope. So basically the general rule is, if it's going to be bigger than 2 terabytes, choose GPT. Smaller, either one, but bigger than that, GPT. GPT contains an array of partition entries describing the start and end of the LBA of each partition and disk. It supports up to 128 partitions and theoretically 18 exabytes of size. So that's a lot bigger. Okay. It enhances reliability, supports boot disks on 64-bit Windows operating system and the UEFI file system. UEFI system, sorry. That's just a different type of firmware. Then we're going to talk about dynamic disks. So we have the basic disk, which basically allows you to create volumes, partitions, all that kind of stuff. But we need to convert it to a dynamic disk before we can create what's called span volumes, stripe volumes, and mirror volumes. Okay, let's actually quickly talk about what a span volume is. Let's say I've got 3 hard drives here, 3 small hard drives. Each one of them is about 10 gigs. But I really wanted to make a really large, use them all as one big area. What a span volume does is just get the 10 gigs from one hard drive, the 10 gigs from another hard drive, and then 10 gigs from another hard drive, and creates a volume across all of them. So I will get a 30 gig volume rather than 3 10 gig volumes. Well, makes sense, doesn't it? If we got 30 gigs to use, why put a little bit here, put a little bit here, put a little bit there, when we can make one big one, and it will take care of writing it. Well, that's fine. What's the difference between stripe volumes then? Stripe volumes, span volumes just uses the disk space up, but where it stores it, yeah, we really can't tell. It could be storing it on this first bit and keep on writing until it gets to the end, right? But there's stripe volumes. Stripe volumes means if I've got a file and we've got 2 or 3 or 4 hard drives and we've created stripe volumes across them, we'll put a little bit of each of the file on each of the hard drives. You're probably wondering why. Why are we breaking up a file and putting a little bit on each hard drive? Could you think of any advantages to that? Speed, how so? Yeah, you're absolutely right. So if we got a 10 megabyte file and we got 4 hard drives striped, instead of writing 10 megabytes to one hard drive, you're writing, let's say 2.5 megabytes per hard drive. Less to write, faster to write. Same with reading, speed, okay, improves performance. Then we have mirrored volumes. Mirrored volumes is a form of redundancy. So when we have mirror volumes, we got a volume, and we on one physical disk, and we'll create another volume exactly the same on another physical disk. If one of them fails, we still got this copy, haven't we? It's like a constant hot backup. What you write here happens here. It doesn't protect you against accidental deletion of files. It's not a true backup, but it protects against hardware failures. Okay, you get me, guys? It's just, yep, question? Yep. Yep, exactly. So like I said, it doesn't protect against accidental deletion because it just thinks you know what you're doing, but it does protect you against hardware failures, okay? So it's not a true backup. So if in that situation, you would have to do a true actual backup, like use the Windows backup tool, for example. Dynamic disk can contain up to 124 volumes. It's funny that these numbers keep on cropping up, don't they? 1024. Anyone know any relevance of that? No, not terabytes, but similar numbers.
It's the way that it's broken up in the bits.
Yeah, it's still a bits. It's binary. So you remember the power of 2s? So it's 2 to the 0 is 1. Then 2 to 1 is 2. 2 squared is 4. Then 8, then 16, then 32, then 64, then 128, then 256, then 512, then 1024. These numbers keep on coming up because they're binary. It doesn't matter if it's an IP subnetting, it's in your amount of memory, it's amount of hard drive space, amount of volumes. You got to understand it's a system. It's a binary system, isn't it? So it's all of IT. It keeps on cropping up. These dynamic disks can be created from basic disk without any data loss. We just convert it. It requires all volumes to be deleted when you convert them to basic disk. So if we convert it from dynamic back to basic, we have to delete the volumes. So it's easy to go from basic to dynamic. Not so good going back. Okay. Can be managed by using the disk part or disk management. Let's look at some of these tools. Okay, so disk management is a graphical user interface. This part is a command line, and PowerShell is PowerShell. We all know what PowerShell is, right? That's a special command line that's in all Windows. So let's actually have a look at let's look at my system. So to start Disk Manager, we can do it many ways, but the way I like it is to right click on the start button and select Disk Management. On this computer, I've got one disk, one CD-ROM or DVD-ROM. And on this 0, so you notice that it always starts from 0 as well in IT, counts from 0. I've got these partitions and this unallocated space right in here, 2.36 gigs. I'm not sure why. It could be part of the imaging process they deploy. They don't know how big the hard drives are, so they just make up a number. So I've got this unallocated space, but I can see that this is my C drive. These don't have drive letters. They're specifically there for some special reason. But here, this is my unallocated disk space. I can right-click New Volume. I'll use up all the disk space. I'll create call it New Volume. I'll finish it, and there it is. It's a D drive now. And if I go to my Windows Explorer, there's my D drive. Create a new file. There it is. It's storing on my D drive. I don't want this. Oh, it's too big. I should have shrunk it. So it was using 2.3. I used 2.3. How much space do I want to get back? I want to get back 1 gig of storage. So I can just shrink it by 1 gig. And there's my free space again. I can create another volume now. And again, there's my new volume. New file. Okay, you see how that tool is fairly straightforward to use, isn't it? Oh, it's straightforward once you learn how to use it. But let's say this one, oh, that's not really what I want. I'm gonna delete it. Yes, but you got to understand it will delete all the files as well. This actually is not big enough now, so I can actually extend this volume. I'll just add all the remaining space. Now I've just made it bigger. Okay, so this part and the PowerShell is not something we're going to go through here, because obviously most of us are just still learning this, so we use the easy tool first. But just be aware that you can do it with this part in PowerShell. This part in PowerShell lends itself to be used in scripts because they're command-based. So this management tool allows it to manage disks and volumes, both basic and dynamic, locally or on a remote computer. So we can actually do things like create virtual hard disks. Let's see if we've got that here. Actions, create a new virtual hard disk. Where we're going to put it, it's a file, don't forget. So we might put it on one of these new volumes. I'm going to call it alex.vhd. And we're going to make it dynamically expanding, and we're going to make it 1 gig or thereabouts. There's a 1 gig virtual hard disk now. Let's initialize it. We're going to, how we said we can do it as MBR or GPT. Let's do it as MBR because it's so small. And now I can create a new simple volume inside of that and now use it. So there's my new volume, new file. That's inside of this new volume. But what's that volume? That volume is a virtual disk, isn't it? Where's that stored? That's actually stored here. There it is. There it is. That's a virtual disk is just a file, like your virtual machine, virtual hard drives. It's just a file, it's right there. But it's actually mounted as a real volume here. Okay, you get me, guys? Why do we want to do that? I don't know. Not usually on a normal computer, you wouldn't do that. But let's say that I had a specific installation of the operating system. We can even make this bootable. So this system will boot that from that virtual hard disk rather than the physical hard disk. You get me? So we can get quite fancy. So this part is scriptable command line utility. We can create scripts to automate disk-related tasks. It always runs locally, runs command from the disk part command prompt, like list disk, select disk, convert GPT, as some examples. There's the PowerShell. I've been saying it quite a lot. Anything you can do with any graphical user interface on Windows operating system, you can do with PowerShell. It's a very powerful scripting language, and you'll be learning all about it in a subject called Create Network Scripts. So we're going to leave this for now because like I said, we're just learning how to do it rather than getting to that level where we know all about partitioning and volume that we can do with the PowerShell scripts. So disk management tools, we can convert, can use disk part or PowerShell to convert partition styles from MBR to GBT and vice versa. We can create simple volumes, like I just showed you sort of quickly, and we can give them a drive letter. And you know what? If I decide that my drive letter was wrong, this is F, I really want to be, I really don't want to use F. I want to change it to X because I'm secretive and mysterious, so I'm going to use X. But just be aware that if you change the drive letter, you change every path. If you have a shortcut on your desktop referring to that F drive, it is no longer accessible. If you have programs which are installed on the F drive just then, and we've tried to change the drive letter, it is no longer accessible. Simple volumes that encompasses available free space on a single, basic, or dynamic hard disk can be extended if there's contiguous space. So the term contiguous is like, I know it's a weird word, but have you heard of any other word that's similar? Sorry? Continuous. So to be honest, you could think of it as like that. Contiguous space means all the space is continuous, if you like. One comes after the other, after the other. So which means that we can actually extend this to more space which continues on from there. Contiguous, continuous, similar, okay? If you extend a volume into non-contiguous space, the disk will be converted into a dynamic disk if it's a basic disk, and it then becomes a, you see, oh, sorry. You see that F drive goes from here to here. So you can't do that on a basic disk, but you still can add to it. It's not ideal, but you can do it, okay? And then you notice that that's all on the same disk. But then if you actually have multiple disks, we can create mirrored volumes. You can see both of them are F drive, but they're identical. So if you're using 9.7 gigs, you are going to be using 9.7 gigs here as well. Both identical. Span volumes, it just adds up space from all different hard drives, makes it into one big one. They don't have to be the same size. You can see that's 1.9, 1.4, 3.9. They just adds it together. Consolidates it together. I can't think of the word anyway right now. Then you have the stripe. Stripe, remember, is breaking up that file into equal parts and storing on the different disks. You notice that in order to be striped, they are identical in size. Okay. Managing existing volumes. So we can resize it, we can extend it, we can shrink it. Like I showed you just before, it's quite easy if you got the space. It becomes trickier if you don't have contiguous space. We can also monitor storage. Okay, so this is fairly important. Just because you got the storage, how do you know how much you used, and if there's a web for controlling access? So let's actually open up my system again, and we can go to storage. Oh, here's my hard drives. There's my X drive. Oops, I should not have clicked on it. There's my C drive. There's my other new volume. You can see that on the C drive, I've used 169 gigs of the 235. On this one, I've used that much. It shows me how much is free. Windows can automatically, let's turn it on, automatically free up space by getting rid of files you don't need, temporary files. If we turn that on, it just basically goes through and removes temporary files. We can also change how it frees up space by doing it, like here it's saying doing it during low disk space. We can say do it every day, regardless of how low the disk space. Temporary files, anything that's over 30 days, or let's just say anything over 14 days we can get rid of. Delete files from my downloads. You know how it is. You click on something, it downloads. You click on something, it downloads. You never clear it up, do you? So maybe I'll say I'll clear up after every 60 days. Just be careful, you'll delete it. So I might just change this to never, just in case someone else is using this. Let's go back. If I click on any one of these hard drives, let's say the D drive, I get into the D drive and now I can see, oh, I've used that much. Oh, systems use that much. Apps, games, files, mail, all those different types of files use up that much. And I can refresh it just so it's like it's the latest information. And what if I find that I'm sharing this computer with people? Cover that. What if I'm sharing this computer with people, and it's not fair. Some people use more than others, etc., etc. And also, how do I know? How much my apps are taking up? So we can actually change more settings. Change when new content is saved. This is basically changing the default location of where things are going to be saved, like apps and so forth. If we actually go to the C drive, you can see that this is more realistic to what is realistic on our computer, whereas the D drive is not an operating system drive. Look, oh, look, apps are using quite a bit, 10 gigs. Let's click on it. Whoa, let's see what's using what. Oh, this is filtered by name? No, let's filter by size. All right, now this is an issue. Oh, is it? VMware Workstation, it's using 791. That's fairly important to me, so it's not an issue. But you can see, hey, oh, this VLC player is using 169. Maybe that's something I don't need it that much and I can uninstall it. You see how you can break down how your storage usage is being used? All right, getting back to what if this D drive is fairly small, isn't it? This D drive is fairly small. I can right click on it, I can select properties, and I can see that, oh, this has only got 2.3 gigs and I'm using 50 megs. It's fairly small. I can do a disk cleanup at this stage. And basically this disk cleanup allows me to empty the recycle bin and clean up the system files. And basically if I had any of those, it will delete it. You guys all with me? Am I going too fast? Okay, good. Because I think a lot of this is everyday use anyway. We can also compress the data. What does that mean? You know, compression is like zipping, but it's not zipping with WinZip or something like that. It's just going to compress the files that are on this volume so that it takes up less space. Takes up less space is great because we have more space to use them, don't we? So taking up less space and compressing it means downside. There's a downside as well. If you compress something, it takes CPU power, memory to actually compress it because it goes through an algorithm to make it smaller. You can't just delete things out of it to make it smaller. That's not how it works because you have to be able to uncompress it as well to be able to use it. So every time you compress it, right to that drive, you have to use CPU and memory. Every time you want to read from it, as in you want to open up the file, it has to decompress and use CPU and memory. So you can see how it could affect you trade off your storage for performance, aren't you? So I can compress it, definitely I'll compress it. And I can also go to my tools and I can actually see, oh, check, is there any system errors? I'm not sure. Let's scan for some errors. Just today, my portable hard drive, I think I dropped it or something like that. When I plugged it in and it said, oh, there could be some problems. So you want to fix it. So I scanned it and there's even options for fixing it. If I click show details, it's going to open up my, I can't drag it for some reason. Here it is. I'm going to drag it here in my event viewer. Remember, that's our logs. I can actually open up the event. Check this was executed on a volume or a snapshot, checking file system. It's done all that, and I don't think it's found any problems, but you can have a look at the details of it. I'll close that. There's some other tools as well. There's defragmentation. So the way a Windows system works is that you write files to the hard drive, and you write more files, more files, more files. It just fills up. Okay, so let's say, I think I've got a picture of that. So it writes files and just keeps on writing in the free space. But then you delete files. But when you delete this file B, it just means there's free space here, doesn't it? So what happens is the next time I need to write a file, maybe I'll write a bit of the file here and a bit of the file in this other free space because they're both free space. You can see how that file, instead of being one continuous block of data, it's actually got bits here, bits there, bits everywhere. And that's what happens over time, deleting and rewriting over the deleted portions. And basically that's what's called fragmentation. All the files are fragmented. So it's not efficient for the hard drive, or especially hard drives, solid state's a little bit better, hard drives to read it, because the hard drive has to move the reading head from location to location to find all the bits and pieces. So that's not efficient. So what you can do if you find your disk is fragmented is you can click optimize here. Let's not do the C drive. Let's do it's a solid state drive. Let's do the virtual hard disk. We'll analyze. So you're going to have less problems if it's a solid state hard drive. We're analyzing. Optimization is not available. Let's see if we can optimize this other one. All right, and then this optimization actually tries to remove the fragmented pieces. It just reads it to memory, clears the space, writes it to get again in a contiguous or continuous method. We can even look at the hardware and look at what it is. You can see it's the hard drive is that. It's a virtual Microsoft virtual disk, and we can even look at the quotas. So what if someone's using what if people are using the hard drive, putting too much data in this hard drive? I can show quota. I can enable quota management first of all. I can deny disk space to users exceeding the limit, and I can limit the disk space to say, hey, each user, it's only a 2.3 gig volume, right? I can say each user is allowed to use 100 megs. And warning level is at 50 megs. And we will log the events if they happen, and we'll click OK. By pressing OK, we'll enable the system. And then we can actually look at quota entries. And you can see, you can't see really, but this is the SID of the user accounts, and you can see how much they've used. Oh, look at that. This Alex guy has created 4Ks of file. The administrator has created 32.7. That's because of the virtual disk, if you remember. And this is the operating system. All right, let's see if I can actually blow that out a bit. Let's get all of these files. It's not huge, but at least we can actually put it there. And we can actually, you see that was 4Ks before. You can see that's actually 8 megs now, because I've updated, I put more data on. You get me, guys? So this is live information, but you might have to press F5 to refresh it. All right. So folder compression, we spoke about that. So basically NTFS, or uses NTFS file compression to compress files. Uses compression to save disk space. Does not use compression for system files or folders. Compression is configured as an NTFS attribute or property. NTFS calculates disk space based on the uncompressed file size. So even it might be still displaying the same size, but it's actually been compressed. Applications that open the compressed file will only see the uncompressed data. So it does decompression, or yeah, I think that's the word, decompression, before it actually reads it. So what happens if you copy these compressed files? Well, if it's within the same partition, because we can configure a compression for the whole partition, we basically it's still compressed. If we actually from one NTFS partition to another NTFS partition, it loses that compression, and copy the file inherits the compression of the target it's copying into. If we move, it retains the original compression state. If we copy to a new location, it inherits the compression state of the destination. And if we go from a NTFS to a FAT, there's no compression because there's no such thing as compression on FAT file systems. So Quotas allows you to limit the disk space usage on a volume for each user. This Quotas can help you track and restrict disk consumption, proactively monitor available space, and determine who is consuming the space and plan for storage capacity. The problem is, it doesn't matter how big your hard drive is. I'm sure every one of us here, probably we've gone out and got ourselves a new computer with plenty of hard drive space, but you know what? After a while, we just fill it up, don't we? We fill it up because we can. No one likes deleting stuff. So we just keep on filling it up. But the problem is when you have a computer that's shared, just like on these computers here, one person could just fill up and affect others. So that's where Quota can be used. We're not going to spend too much time on this storage spaces. So storage spaces is something that's available in Windows 10, but it's something we're going to look at when we get to the server subject. Okay, it actually basically adds an extra layer to the partitioning volume creation by creating what's called storage pools, where we actually pool all the hard disk resources and then create storage spaces out of that, then virtual hard disks inside of that, which are used to store data. So storage spaces, we use storage spaces as add physical disk of any type and size to a storage pool, and then create highly available virtual disks from the storage pool. To create a storage space, you need the following: one or more storage physical disks, a storage pool that includes the disk, storage spaces from the disk, and disk drives based on the storage pool. And with this, so this is in the storage spaces, and if you're wondering how we do it, we'll learn more, like I said, in the server subject. But under storage, here, manage storage spaces, and this is where we can actually create storage pools, and we won't do it. But with storage pools, what we can do is actually create simple, just like plain old disks, two-way or three-way mirrors. Woohoo! You know how we had mirrored hard drives, just two hard drives there? That's basically mirror. When we say two-way, when we say three-way mirror, so instead of having two, we have three. So you can tolerate two failures now, can't you? There's parity, which is similar to RAID 5. So basically, we'll talk more about RAID 5. RAID 5, as far as the disk manager goes, is only a server 2016 or server thing. On a Windows 10, you can't create a RAID 5 volume, even though it's sitting right there. It's grayed out. So I know we can't create it anyway, but let's delete this. See, it's grayed out. I know we don't have enough disks anyway, but it's not something we can create inside of a Windows 10, but you can on a server. But instead of doing that, we can create parity volumes or parity disks in storage pools. There's also provisioning. There's thin or thick provisioning, fixed provisioning, should I say. It's like that idea of allocating disk space now or not. So like on your virtual machines, if we allocate disk space now, if we have a 20 gig partition, it'll create a 20 gig file. That's like fixed. Thin is like we give you create a 20 gig volume, but it's only as big as you use, so it grows. So let's say we've got many people who need to access the same. We can create lots of disks with thin thin provisioning, and they all just grow to whatever size they need to be, up to the maximum storage space. Obviously, you can't go beyond the actual total storage space. Scenarios for storage spaces. So thin provisioning scenarios makes it easier for storage growth. We can add disks later to actually just increase it if you like. So we can always plug that in. Reliable storage scenarios include we can use the mirroring or the parity to create fault tolerance, which should protect us from data loss from hardware failures. And also performance scenarios. Parity resilience gives better performance with SSDs. Okay, usable for video editing and other high disk I/O scenarios. So the biggest one that we know is the virtualization. Okay, for us, for someone who's doing multimedia, for example, it might be video editing. Okay, so they have their demands as well. What is OneDrive? I think we spoke about this. Why is it coming up again? So I think we've spoken about that. So I think, yeah, I might have to fix this up. But let's talk quickly about OneDrive. We talked about this, but we can enable OneDrive. You must sign in with to your Windows with a OneDrive account, such as your work or school account. OneDrive app for desktop provides options for file and folder synchronization. I showed you that before. You can also buy more storage if you want to, and you can also access the recycle bin. We all know what the recycle bin is. It's an easy way of restoring files you've deleted, which are not permanently deleted, should I say. And we can also configure sharing on OneDrive to share files or folders with each other. We can also restrict access to OneDrive by using group policies or creating URL block lists on your Edge firewall. Sharing data with OneDrive, you can share files and folders publicly. You can share it with individuals or groups. You can grant different permissions, like whether they can actually edit it or not. You can grant individuals or groups permissions to the file or folder via email invites. You can post links to social media, so you don't have to upload them. You can publish items directly to social media without uploading them to the social media platform. And OneDrive has 3 default folders: the documents, pictures, and the public. The public is a scary one if you're not sure what you're doing. If you put it in there, like let's say you've configured your camera to synchronize your pictures, and you suddenly drag all the photos that you've got in your pictures into public, you've got to be careful, because that means everyone can view it. Let's say you have some photos with your friends or family you don't want everyone to see, don't put it in there. Okay, just be aware of that. So these other 2 areas are not shared. Okay, they're called documents and pictures, but they're not shared with anyone. So it's as safe as anything is on the cloud. But if you put in this one, just be aware it will be accessible by everyone. Synchronizing settings with OneDrive, so we can obviously synchronize the theme, password, internet settings, and that's why you guys might have noticed my computer always having this weird desktop for some reason. I'm not sure why I settled on this picture, but it's, I don't know, melting ice. But you notice that I've noticed that every computer I go to, it's got the same picture. So that comes back to this synchronizing of your settings. The whole point of this OneDrive is not just on one computer, it's like on any device, carrying you over from one to the other seamlessly. Your shortcuts, your desktop, your bookmarks on your browsers,